Quadratic relations. Okay, so we just went about linear relations. We're going to talk about some of the background knowledge you guys should have for quadratic relations. On a graph, what shape does a quadratic relation make? Yeah, it makes a parabola. So we have something like this, maybe something like this. These are all roughly types of a parabola. So if we have that shape on a graph, we know we have a quadratic relation. So that's our first one. Second way of knowing is f of x is equal to, let's say we have 3x squared plus x minus 8. What type of relationship is this? How do we know it's quadratic? Well, this one is to the power of 2, but this one is to the power of 1. We always look to the exponent with the highest degree. Whatever the highest degree, that's the type of a relationship we're going to have. Okay, so if it was to the power of 3, we'd have something called a cubed one, but we're not going to talk about that. We're really only going up to the power of 2. So anytime the variable to the highest degree is the number 2, we have a quadratic relationship. Okay, even if there's another one here to the power of 1, that doesn't matter. This guy, you could say, overpowers it if you want. Okay? Finally, if we have a bunch of numbers, of course we could plot them, but we're going to use differences to solve them. Now, ideally you got to try the first differences. We try our first differences, and then if they're not the same, we try something called second differences. So I take 32, and I subtract 8. I'm going to need somebody's help as we go through these. 24. Great. 72, subtract 32. Good. 128, subtract 72. Oh, there we go. 200, subtract 128. 72. Good. 288, subtract 200. 88. Okay, so is this a linear relationship? No. Our first differences are not the same, so we know it's not linear. So what we do is we take these differences and we subtract them again. This is called second differences. Second differences, if they're the same, give us quadratic relationships. So we take 40 and we subtract 24. What do we get? Good. Then we take 56, subtract 40, 16 again. 72, subtract 56, 16. And 88 is 16. Okay? So, our second difference value was 16 in this case, which means this is a quadratic relationship. Okay? And we're talking about minutes in strength. So, every minute that passes, somebody, namely me, gets stronger. So, domain. What is the domain for our minutes? How do I start it? That's right. Because time is consistent, it is continuous. Our lowest value is 2. Do I use X or Y? X. What's the highest value we have here? 12. Okay. And the range? Yep. Such that 288. Perfect. So you guys got domain and range down also. Okay, so those are, we just did quadratic, and just before that we did linear also. Okay?